So the next thing to understand is why does a convex lens converge the light to a point, and why does a concave lens diverge light to a point? And it's to do with refraction. So if you zoom in on this, what they've done is they've chopped this up into prisms. That's why it says converging prism instead of, I just wrote lens there. And so I'll just lock this. So if we remember let's just recap. Refraction. So if we have that as an interface, I should really be drawing on a straight line when I'm doing ray diagrams, so I'll do that. The mirror can be a bit irritating drawing straight lines sometimes. Right, so that is my interface. In other words, we're going from one medium to another. So we're going from air to glass. So we need to remember what happens when we go from air to glass. So that is my light, my ray of light that's incident on the interface between air and glass. And let's also draw the normal. So the normal is always perpendicular to the interface and exactly at the point that the ray is incident on that ray of light. Okay. So we've got a ray of light coming into that interface at that point. I don't know why I didn't want that to be green, really. Never mind. Okay. So yeah, it's coming into that interface now. When light goes from air to glass, it slows down, and when any wave slows down, it moves towards the normal. Now, I'm not going to explain why that does that at this point. We're just going to say that it does, and you can recap previous videos if we're not sure why for now. So it goes towards the normal. That's what we'll just say for now. Let's just lock all that image there. Right. So when a ray of light goes from air to glass, it goes towards the normal. So you see it would have gone around about here, but it's moved towards the normal, that dotted line, which is right angles. And if it went from glass to air, it would go away from the normal. So if we look at this here, if we zoom in on this, this is where you have to, it can be a bit tricky to get your head around. So that's the point where we have to draw the normal, and it has to be at 90 degrees to the interface, which would be about, I guess, like that. Just going to set that up a bit better. That's a bit fiddly. Yeah, I guess that's about, well, that'll have to do. So the ray, so you can see that. So that's the right angle there, and that angle there is the angle of incidence, and this angle here is the angle of refraction. So you can see as it's gone into the ray of light, as it's gone into the prism, it's gone towards the normal, right? Can you see that?
Yeah.
And if we did the opposite, if we did one at the other end, we could see in the same way, it's now gone away from the normal. So it would have gone like that, but now it's gone away from the normal. This is the normal here. So you can see that a lens this shape would cause a ray of light to go towards the normal as it goes in, and then away from the normal to go out, which would be because of the shape of this bit at the top, it causes it to sort of bend towards it, and the opposite the one at the bottom would do the same. And if you look over here with this one, you can see it would do the same thing again, go towards normal. If you visualize where the normal is, you could see that it's going to bend towards the normal and away from the normal on the way out. So this general idea about how refraction happens explains why it causes light to converge to a point in a convex lens and diverge from a point at a concave lens.